Hi guys, it's McKayhan again. So in this video we're going to discuss triangle inequalities. So first of all, let's make sure we understand that the longest side of a triangle will always be across from the largest angle of a triangle. And the same thing with the smallest angle. The smallest angle will always be across from the shortest side. So, and the middle side, the second longest side, will always be across from the second largest angle. And that kind of makes sense. If you think about a door opening, or like this would be the hinge of a door, that opening is going to get bigger the more you open that door hinge. So let's go ahead and apply this, and let's list the sides of this triangle from smallest to largest. So first of all, I want to make sure we are reading the directions carefully. We're going to go smallest first, then the largest. So the smallest one will be across from this 48. I like to mark them with these little tick marks. And then the second largest will be across from this 54, so that's going to be the second largest. I'm going to do 2 for that one. And then 78 is the largest angle, so this side across from it is going to be the largest side. So all I have to do now is just list those sides in order. So I'm going to have DF first, then EF, and then DE. All right, now on this one we're going to list the angles, and we're going to go from largest to smallest. So please read directions very carefully when you do practice problems. All right, so again, I'm going to mark some angles here. My smallest side is 4, so the angle across from that is T. I'm going to do a single arc there. My middle length is 8, so I'm going to do the angle across from that with 2 arcs. And then my largest side is 10, so the angle across from that is going to get 3 arcs for me. So now all I have to do is list those from largest to smallest. So I'm going to list U first, and then V, and then angle T. So another inequality that we need to take into consideration is that in order to make a triangle, the sum of the 2 sides has to be bigger than the third side. So any 2 sides. So if I take this same triangle, these 2 sides have to be bigger. When I add them up, they have to be bigger than this third side. Or if I took these 2 sides, the blue sides, they have to be bigger when I add them up than that third side over there. Or if I took these 2 green sides, when I add those up, they have to be bigger than that third side. So let's do some examples. So they're asking us in these 3 problems, can the lengths form a triangle? Well, technically what we have to do is ask ourselves, does 5 plus 7, is that greater than 13? Is 5 plus 13 greater than 7? And is 7 plus 13 greater than 5? See how we did all the combinations that they provided. Now, let's think about this for a minute though. If I'm going to use the biggest side, like 5 plus 13 and 7 plus 13, since this is the biggest side, isn't that automatically going to be bigger than anything else than this side over here, than 7 or than 5? Just by itself. And then if I add something to it, it's automatically going to be bigger. So really when you're doing these problems, you don't have to bother with these 2 options. We really just have to test if the 2 smallest sides, so these 2 are the 2 smallest sides. We need to add those up and make sure they're bigger than the biggest side. So let's do that. So is 5 plus 7, that's 12, is that bigger than 13? Absolutely not. So that doesn't make a triangle. In fact, what happens is we have this bottom side would be 13, and then we have 5 and 7. They don't quite meet up. So it's like it wants to be a triangle, but it's not quite. Let's do another one. Let's see. In this one, we're going to have to ask ourselves, does 6 plus 9, is that greater than 12? So 6 plus 9 is 15, and 15 is definitely bigger than 12. So yes, we have a triangle. And then this last one, again, the 2 smallest sides are 10 and 15. So we're going to ask ourselves, 10 plus 15, is that bigger than 25? 10 plus 15 is 25. So what do we do with that? They're exactly equal. Well, that doesn't quite count. All right, is 25 bigger than 25? No. So this is not a triangle. And what happens here is if this bottom side was 25, then this would be like 15, the blue would be 15, this would be 10, and they just lay flat on each other. They meet up to each other, but they lay flat. They don't have enough length to actually create a triangle. It just looks like a straight line. So now what we're going to do is describe the possible lengths of the third side. They're going to give us 2 sides of a triangle, and we have to say, well, what could that third side be? Now that third side, we don't know what it is, but it could be like the smallest side in the triangle, or it could be the biggest, or it could be even the middle. But we're going to get a range of answers, and the middle one is definitely going to be in between the smallest possibility and the largest possibility. So the largest possibility is if I were to add those two together. All right, so if I add 6 plus 9, then that's going to give me 15. So I don't want it to be any bigger than 15. Otherwise, those two aren't going to add up to be something bigger than the biggest side. All right, so 15, I can't go any bigger than 15. Now, on the small end, I need to subtract them. So if I subtract them, I get 3. So now if 3 is my smallest side, I can't go any smaller than 3 because then 3 and 6 wouldn't add up to be bigger than 9. So this is all we have to do. All we have to do is take these two numbers, add them, and get the big number, and then subtract them and get the smaller number, and that's going to give us our range. So our third side is going to be between, it's going to be greater than 3 and less than 15. Or another way you could say it in words is that the third side is between 3 and 15 units long. All right, so let's do the same thing over here. So now that we know how to do that, we're just going to crank it out. So I'm going to do 4 plus 12 is 16. That's my top end. And then 12 minus 4 is 8. That's my low end. So my third side has to be between 8 and 16. So that's what we know about triangle inequalities. Let's now review what we remember about Pythagorean Theorem. Remember, that's just a squared plus b squared equals c squared, or if you like to think of it in terms of the legs of a triangle, of a right triangle, we have a leg squared plus a leg squared equals the hypotenuse squared, and there's a diagram there. So remember what we've done. In order to find that third side, we're going to plug in our values into the Pythagorean theorem. So if I do that, I get 5 squared plus 12 squared equals c squared. And then I'm going to square those things, so I'm going to get 25 plus 144 equals c squared. And then I'm going to add those together. So that gives me 169 is equal to c squared. So if I want to solve for c, I need to take the square root of 169, and that gives me 13. Now over here, the missing side is a leg. So I need to do 7 squared plus b squared equals 14 squared. I'm going to square those values, so I'm going to get 49 plus b squared is equal to 196. Now, in order to solve for b squared, I have to subtract the 49 over to the other side. So when I do that, it gives me b squared equals 147. So now in order to solve for b, I need to take the square root of both sides. So when I do that, I get b equals 12.12, about. It doesn't come out evenly. So that's a review of Pythagorean theorem. Now what we're going to do is see whether a triangle is a right triangle or not. So if this is a right triangle, then it should work in the Pythagorean theorem. So that's what we're going to do. We're going to set this up as if it would work. So we're going to say, all right, 6 squared plus 9 squared is equal to 3 root 13 squared. Now how did I know this was the hypotenuse? Well, if you were to actually type that into your calculator, you would get about 10.8. So if you're not sure if that's the biggest length, go ahead and put that in your calculator, and you know that 10.8 is longer than both of those. So I know that's my c squared, my hypotenuse squared. Okay, so now we got to square them. And please, 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 don't put 10.8 in here and square it, because then you won't get an accurate number. We actually want to put in that 3 root 13. So if we square those, we get 36 plus 81 is equal to 117. All right, so we still don't know if this is true. I should have put question marks there. But then if I add those two together, I do get 117 is equal to 117. So this is a right triangle. Yay. I've shown that it works in the Pythagorean theorem. Now over here, we're going to do the same thing. So I don't like that being there, is 24 squared plus 16 squared equal to 29 squared. So that's what we're going to do. We're going to square those values. So that gives me 576 plus 256. And we need to see, does that equal 841? Well, if I add those two together, then that gives me 832. And that is definitely not equal to 841. So this is not a right triangle. Now, something to think about though, if this is not a right triangle, then it has to be either acute or obtuse. So I want to think about this. If we were to actually make this a right triangle, so if I were to use 24 and 16 and make it a right triangle, then it would look like this. So if I were to take 832 and square root it, I would get 28.8. All right. So this is what it would actually be as a right triangle, and this is what it is over here. So if I'm comparing this one to this one, this third side, this longest side, is bigger than this third side in the right triangle. So if I'm going to make this side be bigger, all right, that has to be bigger. So I'm going to be making that even bigger. So I'm going to put a plus side for making bigger. Then this angle across from it has to be bigger, right? So this angle has to get bigger. So if this angle gets bigger, then it's going to be greater than 90 degrees. So any angle bigger than 90 degrees is obtuse. So that means this angle over here is an obtuse angle. So that means this triangle is really an obtuse triangle. All right, so it's not right, it's obtuse. So this is just a reminder, you might want to write this down. This is what we should get in a right triangle, is 832. And this is what we actually have. So another way to think of it, rather than redrawing out this triangle, you could just say, well, what do I have to do if this is what a right triangle is, and I'm going over here, I'm actually getting bigger, right? So if I'm getting bigger, then I'm making that angle bigger, and that means it's obtuse. All right. So let's do a few more like that, where we have to figure out what kind of triangle it is if it's not right. So in this example, they're asking us about, well, they're asking us two things really. They're asking, can these lengths be a triangle? So that's like what we originally did. So with the inequalities. So we first have to ask ourselves, can the two smaller sides be greater than that third side? So is 2.8 plus 3.2, is that bigger than 4.2? And yes, it is. They add up to be 6, which is greater than 4.2. So yay, we know this is a triangle. So now we can go on and say, okay, if this is a triangle, then is it going to be right, acute, or obtuse? So we're going to use the Pythagorean Theorem. So we're going to say, is 2.8 squared plus 3.2 squared, is that equal to 4.2 squared? If it's equal, then it's right. So 2.8 squared is 7.84, and 3.2 squared is 10.24, and 4.2 squared is 17.64. So I just typed that into the calculator. So if we add those up, we're going to get 18.08 on the left side and 17.64 on the other side. So obviously this is not right because these are not equal. But now, is it acute or is it obtuse? So let's figure this out. This is what it should have been if it was right, 18.08. And we actually have 17.64. So to get from the right triangle value to what we actually have, it's getting smaller. So yeah, that angle is getting smaller, so that means we have an acute triangle. All right, one more, just to get the hang of this. So again, same question, can these make up a triangle? And then if so, what do we label it? What kind of triangle is it? So the two smaller sides, do those add up to be the third, greater than the third side? Yes. So 6.1 and 4 and 9.4 add up to be 15.5, which is bigger than 11.3. So we have a triangle. And now we need to check to see if it's right. So I'm going to square those smaller two and add them up to see if it's the same as that largest side squared. So a squared plus b squared equals c squared. All right, so those are the numbers that I get when I plug into my calculator. You can pause and do that if you need to. And then here's what I get. I get very close. I get 125.57 is what it would be if it was a right triangle. And I get 127.69 was what I actually have with the numbers they gave me. So it's not quite equal. And notice that I would have to make this number bigger in order to get to where I am. So this is what the right angle should be, and it's bigger. What I actually have is bigger than what that is. So my angle has to be bigger than a right angle, which means that it's obtuse. So please rewind if you need to, go back and look at those, and we will review more of this in class.